Welcome, welcome, everybody. It's glad to see some familiar faces and names. I'm excited, and some new ones. This is exciting. So I am ready to go about telling y'all more about myself, as well as what I have to offer again, and we'll get started immediately with all the good stuff. So just to let you know, my name is Kessie Sham. I've been tutoring now for 16, maybe 17 years. Give you a little bit more background about me, just for those who want to know. I graduated at Georgia State University in 2010. Didn't feel good enough to really, do my master's right away. Got a lot of people who spoke down on me, didn't feel great about it. Didn't have the greatest GPA when I graduated in my undergrad. It was a 2.42 because no one taught me how to learn. I had one teacher who focused in on me, which was my organic chemistry teacher. Duh. Doesn't mean that Orgo wasn't hard for me at the end of the day, but it took 10 years later. Then I went and I did my master's in chemistry and in public health, and I graduated in 2021 with that. So 10 years later, it's never too late to achieve your dreams. So at the end of the day, just know to stick with it, no matter how many times that you've taken your exam. Just know that your timing is going to be, it's just set for you. Whenever it's time for you to walk through the door, you will. Today, just to let you know what we're going to be going over our SN2, our epoxide, and resonance. No real order, just kind of the order that I choose. Just to give you some ideas of what platform I use. I have a favorite. I'm not marketing what that favorite is per se, but Booster and Bootcamp are very good platforms. It's up to you if you don't want to show your faces. If you do, that's perfectly fine. The session is recorded. Most of my students who are already involved in my group me, you know how I do. I will go ahead and ensure that I get all the videos sent to you. And those who are new, just to let you know, all I'll need is your email address to be provided to me, and I'll give you all that information to grab your information and those items to you. So again, we'll be going over those things. I normally do a session for an hour and a half. So we were supposed to start at 2. I always make sure to give you the full hour and a half. So we'll just finish a little bit after. I will ask everyone to kind of pause their or mute their microphone so that way it doesn't pick up. You also have the opportunity to ask questions throughout the session. So what I like to do is, so we don't have as many interruptions, I go about 3 or 4 questions. Sometimes I forget, so please raise your hand, come off the mic, and just let me know what you need help with that we need to discuss, and then we're going to get you where you need to be. Thank you for those who are already putting their emails in the chat for me. I will go ahead and get that information. Quite frankly, if everyone could just say hi real quick so that way I could capture your names and then make sure that y'all all get the video to be sent to you. And then we can go ahead and, begin. So at the end of the day, I've been tutoring for the DAT ever since last year, when my first cycle, when I had 13 students, and all 13 are in school. My best friend is currently all the way in Boston, getting ready to start her program in a week. So I guess that's going to be you next. So I'm excited, including my student yesterday who just got her 19. So I'm excited. I just can't wait for you to be that next person in this chapter. So what you're going to see now is how I actually tutor. So I have one of the platforms pulled up. I know some of the questions, I'll kind of scrummage through some of the questions while we go through and kind of give you the foundations of what I kind of want to teach you today. And then I also want to go into and show you how to assess possibly your exams, because I see a lot of people who don't understand, and I'll probably have some more videos that get posted on that. When you take your exams on the platform and you get a lower score, but they're projecting it being higher, or you get a higher score and it projects to be lower. There's a meaning for all of those things. So we'll discuss all of that. So what I'm about to do right now is share my screen with you to show you how I go about all my tutoring sessions, whether it's group or individual sessions. So I have the program Goodnotes up. I normally welcome you with a nice little friendly introduction, let you know what we'll be talking about today. I have both platforms up. For those who want to pull up the platform, I'm going to use Boot Camp today. Probably if I decide to do these sessions more often, I'll be intertwining both of the programs so that way you can see. Again, I have my preference in what I decide to use, not really gonna poke and prod at that one, but I will end up writing out all the notes. So this is what I do for my group and my individual sessions for those who are as far as from the east to the west, or north to south, because I have students all over. What I tend to do is whatever notes that I have here, you don't have to worry about writing anything down because I send those items to you. So not only will you get your video today, you will also get this good book notes template for the notes that we'll be discussing today. Again, you have the opportunity to ask your questions. That's how I run my group sessions. Groups aren't scary. A lot of the times, most people don't tend to talk during a group session only because they haven't gotten comfortable in their skin. This is a safe place to ask questions. There are no silly questions because I've heard it all after all the years that I've been teaching. And I'm currently, so y'all know where I currently am in life. I left Georgia State. I was there for 10 years. I was over the general chemistry labs, and I am currently at Spelman College where I teach organic chemistry. So I'm qualified to do what I do. A few other things, so you'll probably see me go a little bit back and forth today between giving you the notes, as well as for those who already know me, they know I have my summary sheet out where if you do need any additional help, where you feel like tutoring may be a little bit too expensive for you right now, that's why I created this. I want to say it's like the be all tell all of everything you will need. I broke it down into the exact sections of what you would need with great notes in details, letting you know your number one thing that you need to know are your functional groups. So I took the time to do this in color only because when I started looking at the booster and boot camp, what they provide, they're great summary sheets. I don't do black and white. I like to make sure that my students are able to see or know directly what's being added, what's being subtracted, whatever the reactions are, just to try to give you that understanding directly of what you need to do. So that's just a little bit of me. Any questions before I get started about me or about what we're going to be doing today? Cool beans. Whenever it's silent, that's when I know to kind of continue. So feel free if you want to come off your mic and say anything to me, and then we'll go from there. We are going to start with epoxides. And I'm going to give you the whole foundation of them. Will I find the problems in every section? We shall see, because it's kind of a little bit all over the place. But then we'll also talk about how to do the application. So you're getting notes and you're getting some information to go with today. So when it comes down to epoxides, when we're dealing with epoxides, epoxides are nothing but cyclic ethers. So this is just giving you foundation for what you may or may not know. An ether is a COC bond. And for epoxides, they are going to be cyclic. So you're going to have a triangle connected to an O. That's pretty much what your epoxide is. So now we have to know how to form our epoxides, which are important. You're going to find that in the alkene section for that. So I'm going to show you the two ways that you can form epoxides. So when you go into that section, this is just a little bit of extra information. So with your epoxide formation, you have two ways to form an epoxide, direct and indirect, and both of them are on the exam. The first way, you are going to go through something that they call a halohydrin. So it's a two-part reaction that normally is written like this. So there's going to be times where a lot of people tend to not understand fully when to ignore the solvent and what order things go into. And that's probably been the biggest struggle with reactions. I tell students who come to me, I am not in the memorization game. You can and you will do well. So there's certain things that I'll tell you, please memorize, because especially for your exam for the DAT, there's certain things you just need to know. So, but in other instances, I'm very straightforward. I'm like, ooh, this part means something and this part doesn't. So you'll see that as we go throughout. So the first part is going to be the Br2 in water, the halohydrin effect. So that one is going to give you your Br and your OH on at the location where the alkene is, and they're going to be trans of each other. That's all the time. So that's a little bit more details in the mechanism aspect. And there's more that you need to know. I created this double bond symmetrical on purpose. When it's unsymmetrical, you actually need to pay attention to where your OH goes. A lot of people get this problem wrong. So for instance, I'll just add a little bit of detail there. So because I'm looking at this alkene, all alkene reactions, you're supposed to pretend your double bond is not there. Look into, so I'm giving y'all a little bit extra today. For anyone who comes to tutoring sessions, they know I'm very extra about making sure y'all have everything you need. Your alkenes, you always stay within the peripheral of where your alkene is. Every so often, there's going to be a time where you look next door to the alkene. That's when we're dealing with hydride shifts, methyl shifts, and ring expansions aren't going to be on this exam, but those would be the instances that you have to worry about. You normally are going to categorize your double bond as primary, secondary, or tertiary. So that's classification of carbons. Please make sure you review that, because this could be enough to make you successful on your test. When it comes to now, when we do the halohydrin, if it was symmetrical, it doesn't matter where it goes. But if it's unsymmetrical, the OH group must go to the most stable location, which would be the tertiary. Because there's an extra methyl right there, that methyl would now just be also forced to have stereochemistry is all that would happen. Then the NaOH is the second part of the reaction. So this is the first part. And then our second part is going to give us, when we deal with the base is now going to create the epoxide. The epoxide is going to be the same stereochemistry as the OH is. So you're actually going to see that as trans. And then on top of that, your methyl will still have that stereochemistry right there. So that's one way to form an epoxide. This epoxide is now what we're going to call, this method is the indirect formation of an epoxide. Indirect just means we're taking the long way to make the epoxide. Before that, if we just had the alkene right here and we want to go the direct way is using MCPBA over CH2Cl2. Don't need to necessarily know the name for those who want to. That's perfectly fine if you want to know the names of that. And if y'all type things in the chat, if you're uncomfortable with coming off of your mic, you're also allowed to do that. I tend to kind of look back and forth at that when I get a chance. So the MCPBA, what you see right here, the solvent, the dichloromethane, another thing you don't need to know right now, that does not take place of the reaction. So the MCPBA is what actually creates your epoxide. And again, epoxides, they can draw it different ways. If they wanted to draw it without stereochemistry, they can. The understanding that you need to know is epoxides are supposed to be cis notation at all times. So therefore, it could either be dashed or it could be wedged. It does not matter. So I'm just leaving the groups themselves as just plainer. But either way, it's always cis. So therefore, that's a really important process. And the MCPBA, another way to also write that would be RCO3H. It looks like a functional group of a carboxylic acid, but it actually has an extra carbon that's there in place. So at the end of the day, that's going to really make a difference. You just have to know your functional. Sorry. Got my mom texting me real quick, letting her know I'm in a session and goodbye. Um, so that's going to be your formation of epoxides. Now for opening of epoxides, which that's what I really want to get into, there's two ways to open an epoxide. An epoxide opening can be in an acid condition or basic condition. So here, so if I have an epoxide, which I'll go over in a problem. Let's go over a problem. So I'm pulling these out of the exams, or the problem sets on boot camp or booster, not booster. I always get those two mixed up. Yeah, I'm on booster. So for this one, here's an actual problem off of the set. So a lot of students I noticed do not know how to classify acids and bases. That's another whole segment all by itself. When it comes to now recognizing your acids and bases, I tell my students one thing and one thing only, and this, put it in your back pocket, can change all of your answer choices. When you're thinking about a base, I ask you to recognize if ever you see Na, K, Li, or Mg connected to a halogen, if you see any of these are going to be cations. So this is going to be the indication you need to see. Therefore, whatever it's paired with will have a negative charge, and that will be your base. A lot of the times when you see the H3O+, the H3O+ has a specific kind of what it's supposed to do, like the reaction itself. H3O+ doesn't necessarily react. It normally tends to protonate something, which means give a hydrogen away. So that's where we may be using that. So normally if you see an oxygen and an H3O+ in the picture, you can kind of insinuate that you're going to get an OH group. H3O+ can also help start a reaction depending on what your functional group is. So everything that I'm saying today is really important. So when you hear me say those key emphasis on functional group, I can't stress it enough how much you need to know that. So when I look at this problem, because I see H3O+, which is an acid, that is not where I'm supposed to look. You're supposed to keep your eye on looking for clues. The clue here is if I see this in any of my reactions, it's a base, and whatever the H3O+ or acid that is provided, that is going to be to protonate and give off a hydrogen. The idea now is for bases, opening of epoxides, they're going to give you a question, which every so often I will also switch over my screen to show you what that problem is. So when you look at an epoxide, I have students who do not really know how to classify an epoxide. So when you do classification, just like I showed you the alkene, you're going to be looking at those two carbons specifically in order to determine the stability of each carbon. So can anyone answer the fact of what is the stability of the pink one versus the orange one? You can type it in if you want to. I'll be looking down. So pink, primary, secondary, tertiary. We're not sure. All right, pink is secondary, orange is primary, absolutely. So how do we determine that? So and anyone who answered it incorrectly, the best way that I can say to look at it is, you see the triangle part with the oxygen? Pretend that it's not there, like literally remove it out of the picture where it looks just like this. So that way you can actually see the pink one is connected over here and to the orange one, making it secondary. So this one would be the secondary one versus the orange one is only connected to the pink one. So that's like the best way to do epoxides. I recognized that with a student the other day, that it was hard to see the primary, secondary, or tertiary. Remember, when we do classifications of carbons, that's between carbons. So here, the reason why you said tertiary would have been you thought this was a carbon, or you're just looking at the line itself. Don't look at the line, look at the actual carbon. So there's only two carbons there. So because now I have two, the rule for bases is it must attack the least hindered side, always. You'll always see when I also see when I tutor, hindered side meaning the least hindered, the lowest number versus primary, secondary, and tertiary. Primary is least stable, all the way up to tertiary is most stable. So you'll always, when I tend to tutor, if there's a definitive statement that I can give, like this is always going to happen, I mean that with my whole heart. So at the end of the day, the base portion of this problem is the CH3 because the Mg connected to the Br is positive. So that means whatever else is connected will be negative. So that means I'm expecting my CH3 to add to where the orange carbon is. And in that manner, what will happen to the oxygen? The oxygen at that time will go to the opposite carbon every single time, and it will become an OH group. So again, when we're doing, and I will give you, let me see if I could find a few of the problems that we're looking at. And so you can see yourself. And boom. So you'll see my screen is about to switch over real quick, and then we'll go over the acidic one conditions, and then we will switch over into the new topic. So you will see now my screen will switch over to the platform itself for you to see. And then we're actually going to start back up with the one that we just were doing, which I think was 25. So this is that one. So based off of there, when you're looking to do process of elimination, so you're getting a lot of gems today for those who are new to see me, how do we do process of elimination properly? Well, one, when I know for certain that it's going to attack the right side and my left side is going to be an OH, let's go down and look for the side that is going to give me an OH on the left side with a methyl. A can stay in there for now because I see a methyl. B cannot because there's not a methyl there. C has a methyl and an OH, that's cool. D has the methyl and OH, and so does E. I actually can eliminate A as well, only because I don't have two methyls there. I only have one. So that automatically gives you now, we're down to 3 answers. Then when we look to the right-hand side, we know that we're adding 1 carbon. Be careful. So you need to see that you have 1, 2, 3 in total in the chain. So that means you're going to add 1 more carbon to make 4 in that chain from wherever the N goes from. For C, it goes from 1, 2, 3, 4. D goes same 1, 2, 3, 4, but they added a magical methyl somewhere else. And the same thing for E. So when you're looking at your answers and you're doing process of elimination, you just want to make sure that you look and you count. Those are my favorite things to say. When it comes to studying, do 1 or 2 more problems. So the same thing here. Again, what did I tell you you have to look for? You should be looking for Na, K, Li, or Mg. So once you see those and you see your functional group of an epoxide, you take a moment and you categorize. Let me see if I can draw on here for you. You categorize and you're gonna assign that carbon here and the other carbon on the other side in order to determine where it's going to go. You can also just look at the 2 sides. The left-hand side has a whole bunch of crap on it and the right-hand side doesn't. So the left hand must be the more substituted or stable, and the orange one would be the least stable. So I know I'm going to add a group, and that group is going to exclude the Na. And all of the cations that I mentioned, Na, K, Li, and Mg, they never add to your answer. On top of that, that can also help you eliminate some answer choices when necessary. And then remember, whenever I open an epoxide, I'm adding the group that they provided me, and the other side should become an OH. So if I'm looking at pictures and I see 2 of the same groups, I can automatically yeet that one out the way. Then when I'm looking at the other ones, we want to see, oh, okay, well, if I don't see at least one OH in the group that they give me, that's also out. So right then and there, I just knocked it down to 50-50. So even though you don't have as much time to take your exam, it's very important to breathe, which sounds stupid, but to read. So breathe, read, count, and look at your problem and what it's providing you. So therefore you can get down to 50-50. The rule is the base goes to the least hindered side. So it better be on the right-hand side and not the left. So A has it on the right, D has it on the left. So we would pick our A and then we would keep it moving. Hopefully that makes sense for the base opening. Switching back over to the notes section. And then when it comes to the acidic way, so if ever we have any type of acid, that now means we're going to attack the most hindered side. The most hindered side, now we understand how to do classification. Now it all kind of depends on how they decide to draw the picture. So again, so this is just me giving you the same problem to apply in just a different manner. So as soon as I would have changed, now let's say this to CH3 over. Sometimes they will show you a reagent that has a positive sign. The positive sign is an immediate indication for acid. If you're not certain if it's an acid, well, if I don't see one of these in the picture, it ain't that either. So if it's not my base, then it automatically falls into that category of your acid. Acids tend to have hydrogens on them. So when you're looking at this picture, just because it has a hydrogen connected does not mean that hydrogen is going to add. Essentially, I like to just break it up like this, even though it's not the true form of the mechanism. The hydrogen is what will create your OH group, and the OCH3 is still going to be your additive part. So when you're looking at that one, we're now going to see again, since this one is your least hindered, we're expecting the OH to go here. So I'll just tell you that H, we'll pretend that's the H that gets added there. It's not, because I'd have to go into mechanisms with you. I'm not doing that. And you don't want me to do that either, even though I'm good at it. And then the OCH3 would now go to the opposite end. So that's how you would deal with the epoxide opening of an acid, to show you some problems. So that way you can believe. Ooh, we're not doing that one because that's a little compounded. That one too. So give me 1 second. Always try to find my little problems. So we'll do this one. And there's the shared screen. So again, the idea right here is looking at the epoxide, so going in a little bit more so you can see. We see the epoxide, we know that we have a bulky side and a not bulky side. Now I have people who have an issue when it comes to the ETs and the MEs or the PRs on their test. ET stands for ethyl, so that's going to be 2 carbons. So if they give you a problem like this, you're adding the O and the ET and not the OH group. Now that you see how I broke it down, that hydrogen is meant to give you the OH, not to be added as an extra OH group to the problem. So now that we're looking at that, we would now know, because it's acidic conditions, I need it to go to the top carbon, the OET. So when I look, I know 2 things. OET goes to the top, and I should have an OH in my picture. So when I look at A, I get rid of it because they gave me 2 OETs. B could stay in the picture for right now. E only added the ethyl, not the oxygen with the ethyl, so that's gone. D has the OET and the OH, and E has the OET in the wrong spot. You see how it became 50-50 that quick? Once you know a rule, life can be simple. I teach on rules and I teach on recognition always. So now that we're between A and D, I told you whenever you open an epoxide, and if I didn't, every time you open an epoxide, it is going to be trans notation. The OH in the group that's being added will always be opposite. So when I see D be the same and B is the one that you would choose, and that would be the end of that. I don't know if they'll allow me to choose it because I am not there. There we go. So now you could see. So a lot of people, look, chose E, which would have been the basic answer. And then you have a lot of people who may have chosen this one, the OET, the 5%. So when you see percentages, it's all because a rule was missing. So at the end of the day, these are the things that you kind of need to process when it comes to figuring out those problems. Does anyone have a question on opening of epoxides right now based off of the rules that were just given? Question is, boom. Does yes, ME stands for methyl, ET, ethyl, PR, propyl, and BU would be butyl. Any other questions for this section? Cool. Awesome. I'm going to take a quick 2-minute break. Then we're going to go into the SN2. And then we'll go into resonance, and then we'll be done whatever other time that we have left. If y'all have specific questions or you're like wondering about one of your problems, go ahead and kind of search your test bank and see, and we'll utilize that time at the end for that. So I'll be right back. All right, and we are back going straight into our SN2 problems. So Now, before we go into SN2, I just chose one of the reactions to go over because a lot of students tend to have just an issue with SN2, SN1, SN2, E1, E2. That section, when I think about college, I don't feel like a lot of people were, I don't feel like a lot of people really understood it, and teachers didn't go slow for us in order to get this material. So don't beat yourself up, but just understand there's a set order of arrangements that need to be had in order for you to determine what is SN2 or any of the categories. So when I study for this section, I tend to like the twos. Other people like ones. I tell you, study one area really well, understand it so you can recognize it, and then it becomes a lot simpler to recognize what the other group is. So when I say hard to understand, I was right there with you until when I was studying, I had to make charts. Charts are my life. If you see my summary sheet, people who know, for those who got the summary sheets, let them know about what my charts look like, because I can't promote me well enough than a student who's using the material. Charts help, recognizing help. The rules are what you need to know in order to be able to move forward. So the way I start any session, I give you foundation. We don't just jump into problems right away. So when it comes to SN2 reactions, a few different things. They're cross-wired. An SN2 or anything with a 2 on it only has one step to get to the answer. Anything that has a 1 in it actually has 2 steps to get to the answer. So that's why I hate this section too, because it's backwards. Another hated section is stereochemistry. That one could go to hell, but that's just me. When it comes to the parts of the reactions, you have 4 parts. You have your substrate, and in English, I always give you in English, that's your starting picture. Because that was another problem with Orgo. No one ever spoke English to us. Your starting picture. Your starting picture when it comes to SN2 reactions needs to be a particular classification. What is classification? Primary, secondary, tertiary. What we were just discussing not too long ago. You're going to start noticing patterns. So substrates for SN2 prefer to be primary or secondary, but never tertiary. If you want to just remove the tertiary completely, be my guest. But no, it loves this one. These two loves the primary, it loves the secondary, and it's never the tertiary. So guess what? When we go into SN1, guess what SN1 loves? The opposite. So that's one technique that you could use. That's why I always tell students, why don't you just go ahead and learn one side instead of stressing yourself out and learning it all, because your brain is tired. Mine is not tired because this is what I do. So I teach it all the time. So that's your substrate. The next big thing that I tell my students to look at is your nucleophile. So you have the nucleophile, and we're going to break up how this normally looks. So let me just move a few little things here. So let's draw out the next problem that I am going to go over, so I could just break down the definitions to you so you know what we're looking at. H, and that's the question. So the substrate is this part in blue. That's your substrate. That's the starting picture. When I look at it, I'm going to see the classification of where what we're going to talk about in a second is going to be leaving group. Your leaving group is always on the substrate. So that also helps you. So this and that are connected. And then we'll talk about leaving group reactivity because that also matters. Then when you have you now see your substrate, you're looking at it, you're like, oop, it's secondary. Remember also for halogens, OH groups, you're going to pretend that that line isn't there. So remember, if you forget to do that, just erase it so that way you can see up that blue line is only connected to 2. That would be the easier way to do that mentally in your head, or just to ignore the OH, the Cl, or the groups other than carbon. So now that we have that portion, now we're looking at this one. We have now what is called your solvent that's on the bottom, and then your nucleophile should be at the top of it. So again, who I am is very color coded. I try to keep things as close to the same color as possible so you can match everything. Your nucleophile, this is a good one. Guess what? It's supposed to be a base. How do we recognize bases? Na, K, Li, and Mgx. I see these cations and I know whatever it's paired with is a base. Ask my students who come to group session or individual sessions how many times I say this. If you see that, boom, I got a base. Yay. Then now the issue is, in a second, I'll explain that after this. So then our leaving groups, I'll come back to my thought, I'll hold on to that. The leaving groups have a certain like ranking order in how they are able to leave. So what I say is, if I have a big bodied leaving group, it's easier to pop off. So it's like, oh, I'm big, so I'm in charge of the room. So therefore, the leaving group matters because sometimes you have a leaving group that's stubborn. The stubborn ones are small. They're small and they actually have a better like bond together. It's like, oh, we tight, we go together real bad. That's gonna be the one those are the bad leaving groups. They don't want to leave. They're like, oh, we together, and that's it. You can't separate us. The big leaving groups, they're like, okay, I'll pop off. I don't care. So those leaving groups are going to be in this order. You have your tosylate group, your OTOS. The OTOS, I can't ever remember what it looks like. All I remember is it has a huge benzene group. It's connected to a sulfur carbonyls. It looks something like this. You can look it up and tell me if I'm wrong or right. I don't care about that portion. OTOS is just massive in size. Then what equates to O-tosyl would actually be water. Water is a wonderful leaving group. And then it goes to your halogens going backwards. So hopefully when you are looking at your acid and base reactions, you know that they are periodic trends that you need to know. There's 10,000 trends on that periodic table, but one is for your halogens and size. When it goes from fluorine down to iodine, they get smaller to larger. So the larger one would now be the iodine, then the next largest, Br. Then we're getting smaller going this way. And again, this side is your best leaving group, and we're going this way to the worst. So as we get to fluorine, also remember fluorine is at that top right corner of the periodic table. It's extremely strong. It's not trying to go anywhere real bad. It's right here. So it's strong and it has a tight bond, so it doesn't like to go anywhere. Another two groups that don't like going anywhere are nitrogens. I can't stress it enough. Be careful with nitrogen. They're not your friend, especially in resonance. And then OH group. I have a whole little saying about a cute little saying to remember why your OH groups are terrible. Just think about when people go to a party that serves alcohol. For those of you who drink, I don't drink, but for anymore, for those of you who drink, if alcohol is served at the party, we trying to stay. We not trying to go. We trying to have a good time. So OH is a bad leaving group. So that would be that for your leaving group. So once you notice you have a good leaving group, you have the proper substrate, you have your base, and now let's talk about solvents. Solvents are important So when it comes to me, I will tell you, if you look at your nucleophile and you tend to look at your solvents, those can really break down the problem for you, to be straightforward. So solvent for this one is going to be what they call aprotic, well, polar aprotic solvents. So polar aprotic solvents. How many people have been trying to figure out what this thing means for the longest since Orgo? Polar aprotic solvents, I'm going to show you the difference between the other ones so that way you can see polar protic solvents. The difference between them is the one that has the polar protic solvent, that means you could have an electronegative atom, oxygen, nitrogen, sulfur, anything that's bigger than carbon. Whatever, when they write R just means carbons or whatever groups is attached to it. We don't care about the R's, just groups attached. What you're looking for is the hydrogen that is connected to the electronegative atom. That is not, so it's polar because this is now electronegative and this is positive. So opposites attract. So that's that. And then on top of that, it's protic because it's able to deprotonate or give away a hydrogen. So when I go over here and say that for SN2, so SN2 reactions are polar aprotic, those mean that you still have the case of having your oxygen or your nitrogen or your sulfurs connected to groups, but the issue is on the opposite side, there are no hydrogens. So they're either things like ethers are a real good one. Acetone is a real good one. My favorite one so I just put R's on both sides so you know it's not hydrogen. Then to remember this side, I like to also think about your letter abbreviations. So things like DMSO, DMF. When I see a nitrile group, which is normally they write it as CN, all of these would be the groups that would fall underneath aprotic. So when we look back at our picture, we're going to notice now that we see our solvent not being aprotic. We're like, wait, that doesn't make sense. How did I have the secondary? Boom, we're good. We got the nucleophile, still good again. But then they switched over and they said this. What the heck does that mean? When it doesn't fall in line, that means it's not an SN2 reaction, but essentially an E2 reaction. Pay attention. Those are the small things that you're looking for to figure out your answers. So in this case, I would expect this to be some type of E2, all because the setup is not completely cohesive with the rules that have been stated. So I wanted to mention both of these because this one really goes for like your SN1 reactions, and even your some E1s. We won't talk about E's right now because they're a pain, but that's kind of how you distinguish the difference of if you're doing an SN2 reaction. So giving you, for instance, still not a good problem because they gave us a whole bunch of these. So giving you one like this, switching over my screen. So switching, and I'll still go back and do the E2 so you can see the difference of that answer. So when you look at this one right here, as you can see, my students who have started this section, do you see that's 80% correct? It's rules. It's rules. It's rules in time. For those of you who are taking your exam and you're about to take it like in a few daggone weeks, days, whatever, I'd be like, look, It's up to you how much you want to stress yourself out. Everyone's worried about the timing which you'll get into school. I get that. But why rush yourself to fall into getting a score that's not the best of your capabilities? If you need time, take it. If this is your second, your third, or potentially your fourth time taking it, I'd rather you push out the day. Take the time to learn the little silly rules, practice the silly rules. Don't just learn them, go into these sections and knock out these problems, learn how to do the problem so you can recognize the pattern per se, so you could get these problems right. But I don't know nothing. I don't have several students who are already in dental school. I have not helped people graduate across the graduation line. But I don't know nothing. I'm just here teaching. That's just me. So at the end of the day, when I look at a problem like this, a little bit more information that I will add to the SN2 section. When you see here's your leaving group, BR is real big bodied, so it's ready to leave. We have then the BR is on a secondary carbon. Okay, so we're in cohesion of SN2. I have a base, and they gave us the answer. Notice something about our stereochemistry. SN2 will always do, and I'm writing this on here, will always do inversion of stereochemistry, which means we better be knowing how to do our R and S notation, because there's going to be times that these two sections collide. But whenever I say inversion, that means it starts off with one stereochemistry and it inverts 180 degrees to the opposite, meaning that it becomes dash now. Now, what was the question asking? They said, what's the solvent? Oh, didn't we just talk about that? The solvent that should go underneath here should be a protic. So therefore, if I look down at this line and I see anything that has a hydrogen on it, I should get rid of it. So goodbye, A. Boom. Goodbye, C. Nitrogen is electronegative with hydrogens. Goodbye. And oh my God, that's a halogen with a hydrogen on it. Did I just eliminate all my answers and get to the answers? My golly, I'm smart. It would be very important that you learn these definitions. So give yourself time, add on grace, then go practice. That is how I go about my business when I tell people to study. Then let me go back to I lost my notes. There we go, the notes. Do we have any questions before I proceed with a few problems? Because I know SN2 be beating us up, and yes, I'll still show you how to solve that problem. No. Not right now. Okay, we love it. Love to see it. We on the same page. So now going back to this question. Now we're going to, oh, so I should have left it flipped on the problem. Let's go to this one. And hopefully you can see it. All right, let's look at it. We now have discussed, and this one actually gave us what we were doing. I didn't want to tell you just yet. So I said Hoffman, when we start getting into elimination reactions, specifically for E2 reactions, you tend to have more of a suggested side the double bond could form on. In organic, when you learned the topic, most teachers told you put it at the most stable location, which would give you what they call the ZATSEF product. Which I'll write down on here for you as well. So E2 tends to have two types of products. They have ZATSEF, which is like the cousin to Markovnikov, and then you have the Hoffman, who is a distant relative to Markovnikov. They are very opposite. So, or anti-Markovnikov. So when I'm looking at this problem and they gave us what it was, or even if they didn't tell us, now you know, if it doesn't match up properly, most likely it's the other two, not SN2, but E2. So if the parameters don't line up, baby, it has to be on the other side and not all the way on the other side of SN1, E1. Don't do that, because we still got a base up here. Take a second. One of my favorite students says, lock in, look at your problem, and make sure you don't switch too far off of the understanding that you have when you finally study. Okay, so when you get this part, now you know a double bond is going to be formed. Number one, your double bond is only going to be formed, showing you, trying to write on the page. So you already know this is a part of your double bond. If your double bond flew away from this area, it ain't gonna be it. Number one, we already know it's not E, so goodbye. Then when it comes to where it could be made, it either could be on the end on this side versus on the other end on this side. If they didn't give us the definition of Hoffman and that we just had to solve it, you also want to look at the size of your base or your nucleophile. This OCH3, compared to an OH group, OH is an oxygen with a hydrogen. The second I start adding groups onto it, it becomes bulkier. As it becomes bulkier, that now means since it's bulky, I have a different location that I need to be attaching it to. So now it's kind of one of those things where as it gets bulkier, we go into becoming an E2 reaction is what's happening. So when we're looking at these, E2, now we know it's elimination, but now the bulkier it gets, we have options. What are those options? Look at the two carbons. You have the one that is orange and you have the one that is green. One is less stable, one is more stable. Now I'm going to ask you this question. The size of the OCH3 group, we're now talking.
Okay, so it's
Make sure you hit mute for me. Thank you.
oh sorry.
You're fine. So when we're looking at the two carbons, whether it's the orange one or whether it's the green one, we still have to classify them. Orange would be primary, green would be secondary. Now let's think about it. So one is big bodied and the other one is not. Now we have the OCH3. What classification of size does that go under? That one's going to also be big. So do I want to attack a big-bodied side with a big-bodied nucleophile? That sounds like sterics. Therefore, it could not happen that way. Hence, the definition of Hoffman is it's going to go to the least stable side. So I better see a double bond being formed on the side where it's the orange side, which means the double bond needs to be on the end, which would give us, I can't click the answer because I'm not there, which would give us the answer of D. When I'm looking at the other answers, I can see, look, I don't have any branches. So branches, things that are sticking out, if the only thing sticking out is the Cl. And when it goes, that whole Cl and the bond is going to disappear, which means you just have a straight carbon chain. So anything sticking out, okay, eliminate that. I want you to, when applying after y'all leave today, if you don't ever sign up, I want you to at least go back and be like, let me just open my eyes and look at these problems to see what's going on. So that way you can choose the right answer and keep on moving. Again, they give you the whole explanation here. I don't care for their explanations. Sometimes they're good, sometimes they're bad. I have people who love watching their videos. Hey, do what fits you best because I want you to just get it right. As you can see, 24% of people chose A because they were locked into the fact that instructors have been telling them for a long time that everything is going to go to the ZATSEF rate. So let's see. I do have a preference on one or the other. Which I'm going to end up doing like a video on it, but regardless, I am a booster fan. They don't pay me to promote them, maybe one day. But boot camp versus booster, they both have great benefits. For those of you who, and I don't care your time frame or your background and how long it's been since you've taken Orgo, you don't keep using that as a crutch. I don't want to hear it. I have people who've not been in school for 5 years, 7 years, 2 years, whatever the case may be. Don't use that. Boot camp is more of a training wheel suggestion, in my opinion. I like the way they separate it, but when you go into their problem section, I don't necessarily like the order of their problems. The booster is more representative of the exam, is what students have told me. one. From my experience, I could see why Booster is better because they teach you how to do the condensed structure and the line structure. We love when it looks pretty like this, but then when they start giving you CH2, CH3, CHs, everybody lose their mind, right? So when you start losing your mind off of that, it's either one of two things. You need to learn how to convert that very fast into line, or you need to get boosted. You need to start training your eyes to see it, in all honesty, or practice. Both platforms are good. That's my extent to that. I like Booster also because of the order of how they introduce things for the section. It honestly makes my job easier. Those who have seen me or who have me as an individual client, they know if they have boot camp, I have no problem. I structure it the way that it should be for them, but the way that they give it to you, I'm not a fan. Even their summary sheets, the reason why, and I tell people this all the time, I can promote my stuff all day long, but I'm going to be straight up honest to you. Both of y'all, whoever got both of the platforms, go look up on your summary sheets. Some of the times, did they even show you how to do RNS notation? Did they show you how to do substitution and elimination? Are some of the areas like lab techniques, certain things that you would want to know about CNMR, HNMR, did they even give you the foundation and how to do those? Or were there only reaction sheets? That's just my opinion, but you gotta open up your eyes. What about Crack the DAT? I have not seen that one. Send me the link. I tell people if you want me to give a good assessment and a good review of whatever platform you have, please tell me the names of the platform and I'll go and research them and tell you for certain because I see things differently and I want it to be easier for you. So at the end of session, go ahead and I'll give everyone my business phone number to text me if you have some other like questions or if you need to sit down and do a one-on-one session with me. If not a session, then like consultation if you have questions about what you need to do. Look, I have time to give y'all, but like I have to just sit down and see what they're giving y'all because I think there's another one that's called, it's like $1,700. I don't know the name of it. Just iPrep. Yeah, iPrep. I heard it's really good if you have iPrep. Baby, you need time for iPrep, but the questions aren't in correlation to your exam. So you got the money, baby, dish it out and pay them. But also, as you dish it out and pay them, sit down and make sure you have at least, in my opinion, anywhere from 6 to 9 months if you want to go through every video, unlock everything, because I hear that she's really good. And I watched a video or two and I like the way that it's like paced, but those are for people who want to learn organic. Baby, you don't have time to learn organic. You need 2 to 3 months of someone teaching you the skill set. And when you start organic chemistry, you better keep studying it all the way up until the day of your test where it will leave you like that. So that's my little PSA announcement. So that way to do what's best for you, in all honesty. Let me see if I could find one or two more problems. Yeah, and it's sad because for those who and it's nothing wrong, like how do you know? Who tells you which one is better? I have come down to really looking at the exams and looking at the just knowing organic and how I would like even the order of like 1 through 13, I would never tell you to go in that order. That order sucks. You will probably be you will give up. If I'm not mistaken, I think it goes like fundamentals, which is like sp2, hybridization, acid base, resonance. Then it goes into naming. You feeling real good about yourself. Then they hit you with stereochemistry, and then all your hope is lost, and you stop studying orgo. Don't do the order. Again, that's just me. I'm just giving y'all what I know and what I can provide y'all that I think would make a better solution for y'all. Looking for a few more problems out of SN2, and then we're going to switch over to a little bit of resonance, which should not take long. But let's go to, I'm trying to find all my SN2. If you have more questions, just throw them in the chat. I'm looking down to see where I could be of help. So again, here is another one. Let's go back to the material of the exam. All right, so looking at this one, boom. We now have, in some of these problems, sometimes I don't write them on the summary sheet, and don't worry, as I flip the screen to like the platform, it also records on the video. So you don't have to worry about that. So over here, when you're this one, and you are looking at this one, you will see we have the leaving group. How do we recognize a base? NALIK or MGX. Ooh, I see abbreviation on the bottom. Ooh, I literally have all my little things, all my ducks are in a row. So I know darn well it can't be an alkene because all my ducks are in a row. Goodbye, D. Do you see, like, this is how you would do things. So, oh, and A, my bad. Go. We love when we can eliminate answers. Anything that has this plus enantiomer thing, we'll talk about that. The plus enantiomers tend to be SN1 reactions, but the DAT does not, they actually don't go over that portion. So when we get into SN1, you'll get one answer, or they may ask you a particular style of definition question that goes along with SN1. So you can also eliminate the one that gets out the enantiomer. Remembering the fact that SN2 has to have all of these specific categories. After you find those categories, then you have to remember the number one thing: it inverts. Substitutes, which means it swaps the halogen, the leaving group, for whatever is connected to the Na. Switch, so I'll see CN in the picture. These are the little things you look for. And then, so that's how you could have eliminated some of the answers as well. And then you need to know that inversion of stereochemistry happens. So I see a wedge, so I better be picking the answer that is a dash. Love to see it. Questions or concerns about SN2? Again, going back to the notes a little bit, because the idea here today is really more so to introduce you to teaching style, how to go through process of elimination. You're actually getting a lot more than just topics being taught to you. And then, of course, information galore to kind of give you where you're supposed to go. So how do we feel about that one? Any questions or concern about SN2? We are good. We are great. I love to see it. Again, for those of you who are just popping in, let me know, just say hi real quick, because I'm going to take a quick screenshot of everyone's name. If I don't already have your email address being provided to me, please go ahead and drop that in too, because it's your lucky day that you'll be getting this material sent to you. Normally after session, it takes roughly about 30 minutes or so, if not a little bit longer, for everything to kind of download. And most likely I'm going to get on live again. Thank everyone for coming. Possibly announce if I'm doing any more of these. Hello, welcome, welcome. Drop the email, because even though you're late, you still on time. The first shall be the last, and the last shall be the first. So you're not missing anything at all. So at the end of the day, you are still getting the video. You are still getting the good notes. And again, these are open to people. So if you know other people who need the information, just tell them to contact me. So that way, if I do have a host another session, they know what it's about. So that way I can allow access to these videos and send these things out to you, just to make it easier. I most likely will send a general video access, so that way I can see, so I can give those out to everyone. And the notes will be in a Google document, Google folder type thing. So it will share out. So if you invite people, let me know who you invite so I can give them access to the folder. That's all I really need for those, because those folders are private. So that's perfect. Thank you, thank you, thank you, everyone. So SN2, take a quick, probably another minute or so break, and then we'll finish this 30 minutes out strong. And I thank you again for joining me today, because hopefully you're learning something is the most important part. So a little 2-minute break, give people and myself time to drink some water, run to the bathroom, and come right back. All right, welcome back to more fun, setting the foundation down for resonance. Who hates resonance here? Raise your hand. I love resonance. Resonance is my friend. Me and resonance used to not go together real bad. We had problems because you know what the problem was? The problem was me. You see, it's just not that I hate everything. You can't hate everything. It is my goal in life to like make people look at Orgo and be like, it ain't bad. Like if I could get that out of you, I'll be good. But yes, right now everything is bad. It just feels terrible. But when I tell you, it's not fun. It's not fun. But at the end of the day, what I realized is probably y'all have the same problem as me. You move too fast. The same way y'all read too fast or you don't read at all. No shade. I'm including myself in there. What happens is we miss the small things on top of the fact that I feel like when Orgo started, what happened was why everyone sucks with Orgo, the pandemic happened. So for those of y'all who got really good grades, congratulations. But I know you didn't get them grades on your own. We just gonna leave it at that. Congratulations on your grade. I understand. But then at the end of the day, right? Let's be real. What happened was anyone who's taken Orgo, if you took Orgo 1, most likely your grade was kind of shaky. Then when you got to Orgo 2, it may have not been that bad, or it could have just been bad altogether. The foundation is everything. You left Gen Chem and they said, ooh, they scared you. They said Orgo is the weed at course and baby, you gonna fail. You ain't gonna be a doctor or nothing. So don't even try it. Number one, that's what they did, scare tactics. It's scary. It is. Number two, I've met people lately that I've been tutoring in a library who've changed their majors completely because of organic. And that makes me sad because the amount of doctors that we could have had, dentists that we could have had because time needed to be spent. The foundation is everything. If you miss the foundation of Orgo, you got in and you were excited to do well, and then all of a sudden it started going real fast, and all the stuff that you missed was the real foundation to your success. That's why I decided to do a few of the topics, a little out of order, but still nonetheless. Okay, you got 3 areas of when it comes to resonance. And yes, this is my personality always. Not turning anything on for the camera. I'm just am who I am. You have 3 styles of resonance. You have your positive charge. You have your negative charges. And you have your radicals. Each one has a different way that you need to look at them. Well, I don't know if I'll get through all of them, but most likely positive or negative charges. We'll try our best to get through those. Positive charges and negative charges, the arrows that you see matter. These are going to use full-headed arrows. Just write it across here. So both of these use full-headed arrows, and this one are for radicals are half-headed arrows. Little things will help you recognize little things you're looking for. When it comes to your arrow movement, sometimes it's like, how many arrows will I have? What am I moving? Y'all are thinking too fast again. Just in steps. Positive charge will always have, you'll use 1 arrow at a time. Negative, you'll use 2 arrows at a time. And radicals, you use 3 at a time. I think I have an old video on my YouTube channel. That may be of resonance. It's kind of to the side. That was when I was beginning, so I'm updating things, so bear with me. A lot of new things are coming out or will be launched really soon, so bear with me. But I think the resonance portion is still up on there. So now, depending on what kind of structure they give you, I am going to coin this phrase. Well, maybe I just won't introduce it just yet, but whenever you're dealing with resonance, it's about one going slow and staying within a particular range. That range is what I call my snapshot. You ever have a friend, you want them to take a picture of you, like, okay, now on 3, all right, 1, 2, not on 2, not after 3, not before 3, on 3. When I think about resonance, you need to stay within 3 atoms at all times before you can move. Do not move any further or faster than 3. So when we get a problem, like for instance, going through, these are the problems that I've chose to do on there. I may have to do them a little bit out of order depending on the charge and the type of atom in the picture. Yep, I am going to have to. So we're going to start this off with 30 actually. So 30 looks like this. So I'm going to show you it in motion. I think I may also have a TikTok on resonance where I probably broke down something in like 60 seconds. I'll probably try to do more of those. My life is busy, y'all. So when it comes to this, they ask the question, which of the following is a resonance structure? Before actually allowing you to see what the answer will be for this, we want to go through and actually learn how to do resonance the right way. Number 1, they gave you a positive charge. So we now know, yay, we're going to use one full-headed arrow at a time. Number 2, we then know we're going to stay within 3 atoms. What are those 3 atoms? Always where your charge begins is number 1. Number 2, there better be a double bond at the start of number 2. And at number 3 should be the end of said double bond. If you don't see that order, you cannot do resonance. There's another special circumstance under which resonance has it's outside of this peripheral, and that one is also a rule. So once you learn the rules, life is simple. So when it comes to this now, what happens is, how do we move the arrows? You use the word that best fits you, but I'm gonna tell you to treat the double bond like this. The 2 electrons make up a double bond. So 2 of those dots make up the double bond. The idea is the positive charge is over here. You are going to move your electrons over between 1 and 2. So what happens? Now my question is, how do we know where the charge always lands? So 1, if ever they ask you, like, resonance arrows are always double-headed arrows, but now it's like, okay, did we touch this double bond? No, don't touch that one because we're not dealing with that one yet. If I'm looking between these 2, purple and orange, I'm asking you the question, which one of those dots were picked up and moved towards the positive charge? Purple or orange? In the group, someone give me a color. Even if you're wrong, it's okay. That's what I'm here for. Color in 3, 2, not purple. You want to know why? So now I want to see if I can actually do this one. So let's say I took this right here, and I'm telling you, so this is just in live motion so y'all could see it. I'm saying now I want to take this and move it over to here. We agree. So if I rotate that, so oops, it did not like me. It said, let's move the whole daggone picture. I don't want that. Let's try this. No, I just put that piece. There we go. Sorry. So when I want to move this, I'm saying I want the double bond to go over here. So if I move the double bond over here, that's where I'm moving the double bond to, essentially. I'm saying I'm picking up the orange dot, essentially, and I'm rotating that picture over. I'm like, why does it want to do this now? Okay, there you go. And I'm rotating it over. That's what's happening. So it's like, pick up the dot and move the dot that's towards the positive charge. So did I ever move the purple? The purple technically stayed in the same location, but it ended up being the orange one that got picked up and moved. So literally think about it almost like a pin, like one of those tack pins. Whichever one you pick up and move or rotate over to the positive charge, that's the one where the positive charge location is going to go. If you don't like that method, that's also fine because I have enough ways to teach orgo. If we're fine, if everyone's cool with this 1, 2, 3 method, when you have this method, eventually I'll patent it, but it's called skip a fella. Yeah, I got stupid things to remember orgo, y'all. So when it comes to, I start here, I skip this fella, and my positive charge always lands on 3. You pick which one works for you. As long as you're within that peripheral, you'll always have that answer choice that way. Where your double bond is, where it starts between 2 and 3, it will then now always land between 1 and 2. Now it's between 1 and 2, and the charge landed on 3. So therefore, if I need to do this again, 1, 2, 3, I pick my 2 colors. I'm saying I'm picking the color to either rotate it over. So not only am I moving this over to the other side, I'm picking the pink one up specifically to move it over. So that's how I know where my charge will go. So now the double bond is here. The charge will now go here. You have your purple that didn't really move and your pink one that did. Or again, start, skip, land every single time if you have that. So therefore, when you're now looking at your problem, sharing the screen, if you knew how to do resonance, number 1, the positive charge will be the positive charge. So when they gave you something like E, how dare y'all just switch it over to negative? What you thought this was? A game? No, can't happen. When I have the positive charge, you also, when you get into the section of Diels-Alder and radical reactions, you're also going to see that you need to know your stability of alkenes and ranking them as far as vanillic, primary, secondary, tertiary, and allylic. For those who, y'all who are wanting the summary sheet, if y'all already purchased it, don't worry about it. I have 2. I thought I was never going to have to update it again, but there's something that I wrote in there that was a little bit ambiguous to how you would solve the problem. So I'm just going to line it all up and update it. So for those of you who have already purchased the summary sheet, thank you, thank you. You will be seeing the last updated versions of the summary sheet. It was only 2 small things like a definition, but little things like that bother me. When you see something like C, whenever you have a charge on the double bond, like specifically on the carbon where the double bond is, there's a charge. I don't care if it's positive, negative, or a radical. It's wrong. That is the most hated position in all of orgo, which is called the vanillic position. So vanillic position is hated. So C would have to be gone. Now, again, remember, if you remember what the picture looked like, did we ever go up here to the ethyl portion? I don't remember going all the way up here. And if I do my count again, I'm looking, sorry, trying to get my little pencil so I can draw. If I'm counting, this is 1, 2, 3. Out of everything, I'm actually going this way. So I have no business up here. Do I have a double bond there? Is my 1, 2, 3 going up that way? No. So why in the heck would they put a charge all the way up there if no business there? Most likely you're going to have 3 answers that are always going to test your eyesight and counting and knowing your foundational rules. If you know your foundational rules, baby, you could get to 50-50. Then we have to think about it. Well, they said resonance, right? If they said resonance, guess what? It needs to have a charge in the picture. Where's the charge in D? Ain't none. So my answer is A. I know I make it look simple. I don't know why you're bouncing so much, but this is how simple it could be, to be honest. So those are the little things for positive charges. When it comes down to, I think we have time to do negative charges. Let me grab the problem for negative. I think that one's 28. 28's a good one. Or let me see if I want to do 26. 28 it is. So 28 is an anomaly. I did it on purpose. 28 is a little bit more of a 2-in-1 problem. I'm still going to just make up one for, so I'm just going to put Kessie's problem so you know. Oh, I'm not definitely showing you my screen anymore. So that may be a problem. The charge will always remain positive for the final answer. Yes. If they ask for resonance, you started with a charge, you have to end with a charge. That's always, because resonance, they would have to ask you a question like, what would neutralize the resonance structure? Meaning when you're done with it, done doing resonance, and all the carbons and hydrogens and everything is equally stable, then it wouldn't have a charge on it. So the answer that they were showing previously, it could have been an answer for stability. If they said, what is the final structure of resonance when complete, they'd have to complete the sentence, when completed through a reaction. Now it's stable, no charge. So little things like that would definitely help out. Then when it comes to, I'm still not showing my screen. That's the problem. I'm the problem again, sorry. There we go, back. So my problem would now be, something like this. So when I have this problem, or, okay. When I have this problem, the idea is hopefully you know how to do formal charges, because when you see negative and positive charges, it's because of formal charges. So this oxygen is lacking a bond, hence it's negative, and I'm giving it the charge to you so you could see it. And when we talked about negative charges, we said they're going to be two arrows meaning that when you do the arrow movement, you could still do the same startup. I start where my charge is, I start where the double bond is, and I end with the double bond. I'm still in my 1, 2, 3. If you wanted to use the same rule and you're like, Kessie, I don't have time to even think about it, I'm going to state that I trust your rules. I'm going to say, all right, now I know that you said the charge should always start on 1, skip 2, and land on 3. I trust you there. Then I know you said if the double bond was between 2 and 3, it should now be between 1 and 2. I trust you. That's the answer. Cool. For those who trust me, thank you. For those who need to see it, because some people do need to see it before they trust me, the negative charge is going to come in to make the new set of electrons become a bond. So the first arrow is always going to make a bond for negative charge, but then when this comes in right here, that carbon will now have 1. This one will be the second bond, 2, 3, 4, 5. In organic chemistry, if carbon ever has 5 bonds, baby, I'm gonna call you 5 bonder like I did one of my students years ago. That can never happen, okay? So therefore, that's what's going to force these electrons to hop over to number 3, yes, and land on number 3, and that's okay. Hence why this and that, those are resonance structures to each other. Now look, I have 2 more double bonds. This is what I was talking about, just in case y'all needed to know. Again, 1, 2, 3. But okay, Kessie, there's another double bond down there. So should I go down there? Well, what's your rule tell you? This is 1, this would be 2, this would be 3. If there's not a double bond in between my 2 and 3, don't you go over here saying, you know what, Kessie, well, I don't know how that's going to be, but I'm just going to hop it over anyway and make that my 2 and 3 and do some dumb-ish. I will fight you. Don't make me fight you. Keep within the parameters. If you notice that it can't be done, it can't be done, which means that this double bond here does not partake in resonance. You just keep going to the one that does. Now, number 28 was the real big problem. Why is 28 the problem? 28 don't have no charge. Lord help us all. Now, another thing that people forget is conjugation. So this would be another topic that's covered in Diels-Alder and radical reaction. And alkenes. Conjugation, no need for the S. Whenever you have double, single, double, double, single, triple, every other bond starting with a double bond, that's equal to conjugation. When that happens and there's no charge present, there's the, what they call is the inductive effect that you would be learning when you get into the benzene aromaticity section. The inductive effect is, let's say, one of my fists aren't equal. So I'm going to say we're connected, but the inductive effect is one is bigger than the other. So even though we're connected, this one's holding a phone. The one with the phone is going to pull it that way. That's the inductive effect, electronegativity. One's more electronegative than the other. That's inductive effect. So when I look at this problem, I'm going to see that the negative is really going to be my oxygen. It's the only electronegative atom, which means the double bond has to flow towards that negative charge. That's called the inductive effect. So what happens is, even though I don't have a charge, I can forcefully move things. Now, how would I do that? I'm moving my double bond, the whole set of electrons, to do resonance towards that. So if I move this over, so this doesn't necessarily have a 1, 2, 3 method to it. If I move it over and I notice inductive effect, that means I'm carrying that whole double bond and I'm flipping it over into the next area. When I flip it over, this carbon now will have too many bonds, which will force this now to go up. So what ends up happening is, due to the inductive effect, I now have where my double bond shifted here, but now the oxygen only has one bond instead of two to be stable. So therefore, when you're putting a negative charge, you get this negative charge through the formal charge reaction, the mathematical way to figure that out, which would now give you this structure as being your answer. But now we have another problem. We moved it over, right? If I flip this over, let's go back and put a little color to our dots. The dot that moved really was the pink dot, because the purple one is still here and the pink one moved there. You can't do anything in chemistry without color, in my opinion. So what happened? This carbon was completely stable. The audacity of you for moving it to get your resonance structure. If it was stable, which means it has no charge on it, now when you move it, I'm expecting the carbon or electron that you picked up and moved it towards now should have a charge. Whenever you take away from carbon when it was once stable, it will now be deficient and have a positive charge. So do not be shocked if ever you see a problem and it has two charges in it. Sometimes there's a reason for that, which could be the inductive effect. So when you're looking at this problem, you can now see what they're giving you is issues. We know that the problem cannot have no charge because resonance happened. So here, they just flipped up this one little endpoint, and D, they had the audacity to move it over and still not put a charge to it. So anything that's neutral when they ask for resonance can't be the answer. We have positives and negatives, cool. Let's look carefully right there at A. Is that carbon with 5 bonds? And then they have the audacity to say there's still more room to add more bonds. Carbon can only have 4. So therefore A is gone. Sometimes looking at the problems make a whole heap of a difference. Oh, we are down to 50-50. Yay. So now again, the oxygen, if you know your formal charge, oxygen with one bond should be negative, carbon, it's lacking is positive. That's, you see how the two, they're going to be very similar to each other. The only thing that you're missing is now a rule. So that would be the biggest thing that you have to be careful of when it comes down to resonance. So again, do we have questions about resonance at all? Amazing. I'll wait and give y'all a second on that note. Now, did everyone make sure to put their information into the screen, into the chat box? If not, it's okay. Again, I just want to make sure that it's there so that way I can provide you the information. The video will be shareable. So if you're like, hey, this girl, Cassie, KhemWIthKess, she knows what she's doing. So at the end of the day, what I want to do is I want to actually like tell people about her. The video will be able to be sent. The notes, when you send it to people, I'm just gonna have to provide them access so they don't have to be scared. They'll get the access. It may show up as no access given. That's just how my stuff is set up. But that way you can share at least the few topics we talked about. Just to recap what we went over today, for those of you who may have joined in a little later, we went over 3 topics: SN2, epoxides, and resonance. Epoxides, we learned how to make them and bust them all open. SN2, we learned the rules and how to apply them, and knowing that definitions are important. And then resonance, we just learned how to shift a few things back and forth and make some things wiggle. So at the end of the day, this is me. This is KhemWIthKess. This is how I teach Orgo. For some people, you may not like it. I may be too entertaining. I may be a little too much, but guess what? I don't make it boring. So at the end of the day, you learn here. If you're the type of student who needs more technical definitions, or you need to know the why, that's fine too. I could break it down in that aspect as well. But because y'all are already so stressed out, all of my sessions, minus the breaks, during my group sessions, it's very rare that I take a break. I go an hour and a half straight through. I took the breaks today because I'm talking a lot. But at the end of the day, you have all of the information here, access to it, access to share it to other people and tell them about me. Of course, in a second, I'll get on Instagram once everything loads up. I have everyone's email address, hopefully. So if no one texted back, so that means I have that one. So I hope it was helpful. Do we have any questions for me or concerns, pricing, information you want to know? Because at the end of the day, if you can put, and I get it, y'all are already dishing out a lot of money. So don't do that. But at the end of the day, when you have someone who is able to do what I do and teach it well, y'all will pay $175 for the DAT classes, where they teach y'all for 3 hours, barely allow you to ask any questions. They don't record the sessions and they don't give you notes. But no one has checked out my group pricing recently. So at the end of the day, you can tell a friend about me. I choose, that's me. And I'll forever promise it's on video now. So if ever I change and you want to like come at me, prices may go up due to time. However, I will always be the one who's thinking about a student's pocket, because I know how much money y'all are spending on bootcamp, booster, applications, and everything else. But at least I know I'm trying to always keep it affordable, reasonable, and I'm giving you what other people want, everything in a nice seal deal package with a little bow on top with my personality. So hopefully I've been helpful. You have any questions, want to know more about me? I'm an open book. Thank you. I'm seeing everyone's email being dropped. Thank you, thank you, thank you. So I'm taking those down. You're welcome. I hope everything was cohesive for you today and you actually learned. So give me some time. I'll get everything together. And if you want, I'll also on Instagram, for those who follow me or don't follow me, you can find me always at KhemWIthKess. You can look me up on YouTube. My website is being developed right now. Right now, if you go to my link tree and my Instagram profile, you will see my pricing. The only thing I ask you to do is wait for the summary sheet. Even if you purchase it, it's not a big deal. Like today, everyone will have the updated summary sheet. Every so often I do sales. You either catch them or you don't. It's the best that I can do. And again, I'll be back. My group sessions, they're about to go, they'll start all over again. So I just finished with my group of like 6 or 7 students in group session. They're getting ready to take their exams. So I hope you join me on the next round of group session, and you can always hop in at any given time. So I hope to see you. It's been a pleasure. Thank you very much for coming, and I'll see you soon. Bye. You're welcome.